Good afternoon, one and all. Welcome to Pantech eLearning. So today we are going to see about introduction to TensorFlow for AI. Okay, so TensorFlow is one of the package used for artificial intelligence. Okay, so today we are going to see about why we are using TensorFlow and what are the applications of TensorFlow and what are the uses of TensorFlow. Then we'll enter into some technical session. Okay, like using Google Colab, I will tell you how we will use TensorFlow and how to import the TensorFlow package in Python language. Okay, so hope this session will be very useful to you all. Okay, so please attend the session till the end. Okay, those who are new to this channel, please subscribe the channel and hit a bell icon. You will be get a notification each and every time. And those who are attending this wonderful webinar, welcome you all. Then let me enter into the session and how we will use TensorFlow in real time and what are the applications are there, we'll see. Okay, so first of all, I like to introduce myself. I am Kamalesh. I am a data scientist for past 3 years. So today I am going to teach you what is TensorFlow and what are the uses. Okay, so these are the table of contents we are covering in today's session, like introduction first of all, what is TensorFlow and why we are using, who introduced the TensorFlow, those things and all we will see on introduction, and architecture of TensorFlow. Architecture of TensorFlow means like how we need to create a TensorFlow package and how to run the TensorFlow package, and next one how to download and install the TensorFlow. Actually we already seen how to install the packages in live session also. I will tell you how to install the packages and all. Then after that about notebook. Why? Because I am going to use notebook file and I will tell you what is the how to use notebook and all. Okay, so if you are in front of PC means you also can work with along with me. Why? Because I am using here online IDE only. There is online software only to run the Python codes. Okay, you also can run those things. So just I will tell you how to open Google Colab and all. You also carry on, and simple TensorFlow examples. Okay, so these are the area we are covering in today's session. This is the table of contents. Okay, let me enter into the session. So introduction is nothing but, first of all, what is TensorFlow? So TensorFlow is nothing but it's a Google introduced the TensorFlow. It's a open source and it's a most popular for deep learning libraries. Okay, and deep learning libraries means for research purpose or for production purpose. They are used mostly they are using this only. And the basic advance of TensorFlow is like we have different type of algorithms like linear regression, classifiers, create, and we can train the algorithm and we can evaluate the neural network algorithm and CNN, RNN. Like that we can do some different type of algorithms sequentially with one another. Okay, we can maximum efficiency of the learning. Okay, so we can do whatever we need. Okay, so the TensorFlow is one of the product. It's a Google product and use it for machine learning only. Okay, so for example, if you in real time the TensorFlow is working in search engine or translation of image captioning. I hope everybody will know about search engine. For example, if you are open your browser, in that browser if you are searching for something, okay, like for example tutorials for, okay, so if you are searching for something tutorials for, you will be getting some suggestions like Tensor tutorials for Python or tutorials for C or tutorials for Java, like that, right? So like
at the time we are using the TensorFlow package. Okay, so it's giving a suggestion from artificial intelligence, what kind of suggestion we need to give. So this is generally called as the TensorFlow, the working of TensorFlow. Okay, not only in search engine, we can take it as a translate recommendation systems also. We are using this TensorFlow AI. And history of TensorFlow, like generally it's introduced in couple of years ago only. Okay, the deep learning is started to outperform all other machine learning algorithms when given the massive amount of data. That is generally why we are using this TensorFlow means because of deep learning algorithms. Okay, so generally if you are training any machine learning algorithm with data, okay, here for example you can take it as a x-axis as a data and y-axis as a performance. And if you are increasing the data for machine learning algorithms, you are not getting an like performance. You are not getting correct performance. Its machine learning algorithm will be not accurately working for massive amount of data. Okay, so that's why we are going to use deep learning algorithms. Okay, so deep learning algorithms will give a nice performance result for massive amount of data. Okay, so that's why we have started to enter into the deep learning. But here one thing, if you are entering into the deep learning type of algorithm, we need some softwares or some packages, right? So for that purpose, the Google introduced the TensorFlow package. Okay, so not one thing guys, the TensorFlow package will be like not for deep learning, not only for TensorFlow package, we have some other packages also are there. Okay, but TensorFlow is the most popular one and most famous one and most efficiency for deep learning algorithms. Okay, so that's why they introduced the history of TensorFlow. Generally, if you take a the Google itself using the deep neural network to improve the services like Gmail. Okay, so in Gmail they are using deep neural network only, and photos. Okay, so definitely you will be know about the Google Photos. Okay, so if you take a Google Photos, they automatically assigned there according to the index of the page, index of the face. Okay, your friend's face and your parents' face. Okay, others your face. Okay, they are assigning the some index of your face, and then it's giving some like index, right? So based that under working under deep neural networks only. Okay, so even I already told you Google search engine. Okay, so these are some of the history of things you need to know. Okay, so history of TensorFlow, and mainly the public. So okay, the first made public as a 2015 only. Okay, while first stable version appeared on 2017. Okay, so I already told you it's a like stable version. It's couple of years ago only it's introduced, that TensorFlow is introduced. It's 2017 only. Stable version is introduced on 2017. Then we are started to using this TensorFlow packages. Okay, so what you have to know, what should you know? Okay, for example, if you are using a TensorFlow, what should you know? Okay, so you need to you need to know about first of all Python language, understanding the Python language. Okay, so if you know Python language, we can definitely use this TensorFlow in as a technical base. Okay, so if you are don't know Python version, that starting of learning about TensorFlow is somewhat difficult. Okay, so you need to learn Python language. Then TensorFlow architectures. Okay, so TensorFlow architecture means like if you are taking any other languages, we have some architecture to define those things, and we can retrieve the data. Like for example, if you take an Android application development, we have model view architecture. Okay, like that MVP, they have different type of architectures are there. Okay, based on that architecture only we have to work and we have to deliver the projects, right? So here in TensorFlow also they have some architecture. What are the architecture means? Like this is the three parts in TensorFlow architecture. The first part is pre-processing the data. Okay, so whenever you are assigning any data by using TensorFlow, you need to give some important keywords, okay, like placeholder, okay, and what is the data types you are entering. Okay, for example, if it is an integer 32-bit, you need to assign it is an integer 32-bit. If it is an integer 64-bit, you need to assign if it's an integer 64-bit. Like that, you need to assign you need to assign some information. So for example, if you take a general programming language in Python or any Java or anything, you need to give, for example, if you take it as a Python, you need to, if you want to assign any data type, any integer or float type, you need to give first variable name, then like 4, a is equal to 4, like that, right? But if you assign same thing in TensorFlow, then it's totally different. Okay, if you want to assign this in TensorFlow, the totally is different. Why? Because for example, if you want to assign the 4 into the variable name a, you need to use some keywords like placeholders, and then what is the data type you are assigning, like that. Okay, I will tell you. Okay, I will tell you how you need to do those things, but you need to know that is pre-processing the data. And next one, build the model. Okay, so build the model means like we need to not only assigning the data, we need to do some other process also, that is building the model. After building the model, you need to train the model and test the model, that is estimate the model. Okay, so generally it's called as a TensorFlow because it's take an input as a multi-dimensional array. Okay, so whatever you are giving an data, okay, those data will be take it as a multi-dimensional array. Okay, not a single dimension, it's a multi-dimensional array. Okay, so generally this multi-dimensional array is called as a tensors. Okay, so generally the multi-dimensional array is called as a tensors, and this is the thing, the TensorFlow architecture. Okay, so this is the TensorFlow architecture. And okay, so this is the thing. Next slide. The TensorFlow architecture, it's called as a TensorFlow. I already told you what is the tensors. Tensors is nothing but it's a multi-dimensional, and you can construct the flow chart of the operation that you want to perform the input. Okay, this is important. Why? Because if you need, for example, if you are adding any two numbers a plus b, you can't directly do this process. You need to give some flow chart. Okay, give some flow chart. For example, I am having an a value, I am having a b value, and I assign this to addition. Okay, after I will forward all this data to the addition, and addition will be occur, and then we will get an output result. Okay, so like this you need to construct some short form of flow chart to connect to operating those operations. Okay, so generally this flow chart will be called as a graph to perform the input. Okay, so what are the inputs you are giving? Okay, for example, here you are giving 2 and here you are giving 3. Okay, so those input will be go into from the one end, then it will be flow into the multiple operations like plus operations or minus operations or multiplication operations, then it will be comes out of the other end. Okay, so this is the flow chart for TensorFlow. It will be go from the one end and the output will be came out of the other end. Okay, so this is generally called a TensorFlow architecture graphs. Okay, so here we have, if you take a TensorFlow hardware or software requirements, we can classify into two types. Okay, so whether if you are using the TensorFlow based on hardware or whether you are using a TensorFlow based on the software, it's not a problem. But we have totally two type of running procedures are there. Okay, so one is development phase, the next one is run phase. Okay, run phase or inference phase. Okay, so what is the main difference between this development phase and run inference phase means,
development phase is nothing but when you are having any data. For example, you can assume that you have a data of pictures of dog and cat. Okay, you have a pictures of dog and cat. Okay, so when you are using this data set, you are training any one of the model is nothing but any algorithm, deep learning algorithm, deep neural network algorithm. You are training the deep neural network algorithm. That's usually called as a development phase. Okay, this usually called as a development phase. That is, you are training the model. By training is usually done by your desktop or laptop. That is, you are training your model by any way, by your desktop or any laptop. You are just training the model. Okay, so this is the development phase. After you are training the model, you will get one new trained model. That is, after you are passing all the trained data, after algorithm will be get trained, so you will have a trained algorithm, right? You definitely have a trained algorithm. Those algorithm is called as a run phase or inferences phase. Okay, once the training is done, TensorFlow can be run on many different platforms. That is, if you are retrieving this trained algorithm as any file, any pickle file, okay, or h5 file, any file, okay, so that file can run in any platform. Okay, that can be run from any platform, whether it's a Mac OS or whether it's a Windows OS or whether it's any other platform. You can run those things. That is called run phase. Okay, now it's in a run phase. Okay, so this is deployment phase, this is run phase. TensorFlow can run many different platforms. You can run on desktop or cloud or mobile devices. Okay, so model can be trained using by GPU as well as CPU. This one is important. Okay, so mostly the GPU will be used for gaming purpose. Okay, but now not only GPU will be used for gaming purpose, we can use for training the algorithm. If you have a large amount of data set, you can use GPUs also to run the data set. Okay, as well as CPU. That is, normally if you have a desktop without the GPU, you can run the algorithm, or you can use GPU also, you can run the algorithm. Okay, so this is the basic difference between deployment phase and run phase. Okay, now introduction to components of TensorFlow, that is tensors and graph. We already seen what is tensors and what is graphs. Tensors is nothing but when you are creating anything like A or B or C, it will be stored as a multi-dimensional array, right? So that is tensors. Graph is nothing but the flow chart. Okay, how it's flowing the operation. So that is graphs. Okay, so this is the basic difference between tensors and flows. In detail, you can see in the next slide. So here you can see tensor is in TensorFlow. All the computation involves the tensor. Tensor is a vector or matrix n-dimensional. So matrix n-dimensional, everybody will know, I hope. Then vector, some of the persons are know and some of the persons are not know. Vector is nothing but it's a sequence. Okay, sequence of digit like 1, 0, 1, 2, 3 like that. So that is vector. Okay, so all the values in tensor hold some identical data types. Okay, with known, partially known, or without known also. Okay, so this is the basics of tensor. And here we have a graph. What is a graph? The TensorFlow makes use of the graph framework only. Okay, why we are using this graph framework means, like, we need to gather some series of computation during the training. Okay, so what are the advantages of graph means, we can do whatever we need. Even you can run it in a CPU or you can run it in a GPU of the mobile operating system. So the graph can be saved to be executed in the future and connecting the tensors together. So this is the introduction to components of TensorFlow. Okay, so the next one, why the TensorFlow is popular. After this we will enter into the technical session. Okay, so be ready with your
browser, I will tell you how to open the Google Colab, and then I will tell you how to import the TensorFlow, how to use the TensorFlow package, and how to build the flow chart of TensorFlow, and how to run and execute the output. Those things and I will tell you easily. Just be ready with your browser, and let me back to the session. So why the TensorFlow is popular? So TensorFlow is the best library because it's a built-in accessible for everyone. Okay, it's a open source, and most of the things are built in. We just need to import the package and just write the code easily. So one of the things, it's a popular. And then TensorFlow library are incorporate different API to build the scale deep learning architecture like CNN and RNN. Okay, so we can build the CNN and RNN algorithms also. It allows to developer to visualize the construction of the neural network with tensor board. Okay, using tensor board option, you can visualize your building of your neural network. If you are building any convolutional neural network, or if you are using recurrent neural network, you can use that tensor board and you can view your neural network architecture. Okay, so that is the use of tensor board, and you can run the TensorFlow using either a CPU or neither a GPU. So that is one of the most famous one. And moreover, apart from this, okay, TensorFlow mainly popular by GitHub only. Okay, it's mainly popular by using GitHub only. Why? Because most of the persons in GitHub, they started to use the deep learning framework by using TensorFlow. So whenever the unknown person are searching something in GitHub, okay, they have only with TensorFlow deep learning framework only. So they attracted with TensorFlow and they work on it. Okay, so these are the things takes the popular of TensorFlow. Okay, so next one, here we have a popular algorithm supported by TensorFlow like linear regression, classification. Okay, linear regression, this will be used for regression type of output also. And here we are having a classification. If you need to find whether it's a 0 or 1 or within range type of output, you can use classification type of algorithm. And deep learning for classification also available, and deep learning for wipe and deep also available, and boosted tree regression and tree classification. Okay, so these are the algorithms commonly available in TensorFlow package. And the next one, how to install the TensorFlow package. So how to install in your PC means, if you need a TensorFlow, that is if you need to install TensorFlow package in your PC, I will tell you. Otherwise, you don't need this TensorFlow package in your PC. You can use Google Colab. Okay, using Google Colab, you can run it straightforwardly without installing anything. It's already, Google Colab is already predefined, already installed IDE. So you can use that one and you can run it whatever you need. Okay, so first of all, I will tell you how to install the TensorFlow Keras in your PC. Okay, so here I am opening. First of all, you have to install the software. Okay, so the software is nothing but it's the name of the software is Anaconda Navigator. Okay, so this is the software Anaconda Navigator used to using this software, you can, if you install this software, the official website is available. You just search it on Google, Anaconda Navigator download. The official website will be available. So go there and you can download the software. The software is available for both Mac OS and Windows OS. You can download which platform you use, and after downloading, just install it. After installing, you will get this options like Anaconda prompt and Anaconda PowerShell prompt and Jupyter notebook, Jupyter node and spiders, those things and all we will get. So if you want to install TensorFlow package, you need to open your Anaconda prompt, and then you can use pip
install and TensorFlow. Okay, so this is the way you can install the TensorFlow package. If you click enter button, automatically it will be download from the online, and the TensorFlow package, the current version of the TensorFlow package will be automatically installed in your Anaconda prompt. Okay, but suppose if you need any particular version of the TensorFlow, you need to use equal to like 0.2.1, like that. You need to give which version of the TensorFlow you need. Okay, so like this way you need to install the TensorFlow when you are using Anaconda prompt. Suppose if you are using Python ideally this Python ideally, the same command what I am showing here, same thing only, but you need to open the Python ideally prompt, command prompt. Okay, so this is the basic things. You need to install the TensorFlow package in your PC, and you can run it your code of TensorFlow. But the other way, okay, the other way, if you suppose you can't able to install the package or install Anaconda Navigator in your PC, means you can use some of the online environment. Okay, so the online environment we are having, like, just to go enter into the Google. Okay, so after you searching for Google, you just search Google Colab. Okay, so after you are open your browser, just search it for Google Colab, then automatically it will be enter into the next page. Here you can click the first link of your page. Then after you are clicking the first link of your page, it will be enter into the next page. The next page is nothing but welcome to collaboratory. Okay, so using this welcome to collaboratory file, using this online source medium, you can create your new Python file and you can run your code. Okay, so for example, here you can see this is the page. I am going to file option. Just wait a minute. Here I am clicking the file option and creating a new notebook file. Okay, after creating a new notebook file, automatically it will be automatically create a new notebook file like this untitled file. Okay, automatically it will be create this untitled file. So this is generally called as a interactive Python notebook file. Okay, the extension of interactive Python notebook, this is the extension. .ipymb file is the extension. So you can create your new notebook file, that is Python file, by using this welcome to collaboratory page. Okay, so note one thing, guys. Previously I told you how to install the package in your PC, but here you don't need to install the package in your PC. Okay, so you just enter into the welcome to collaboratory page, and then you can create a new notebook file. Means whenever what are the package you need, you can import the package easily. Okay, so this is generally called as a notebook file. So if you wanna run this file, you need to use this button. Okay, if you are clicking this button, automatically the particular cell will be run. If you need to create an even more code file, you need to use this code option. Okay, you can create a code file. Okay, so now what I am doing here means I will build the architecture like this. Okay, this is my architecture, creating the computational graph like this. Okay, so this is my aim. I need to create my computational graph. First I will create two variables x1 and x2. I need to multiply those variables. Okay, so what is this session? So we seen about we will pass all the information through the node, and we will compute the operation and we will get an output, right? Everything we seen, but what is this session? Okay, so I will tell you what is this session in detail in technical part. So just I open my Google Colab. After opening the Google Colab, so here we already have a sample TensorFlow example, that is how to create the file. So first of all we need to import the NumPy and TensorFlow, and after that
we need to create a new variables. In that we need to use placeholder. So placeholder, I already told you, whenever you are creating any variable you need to use placeholder, and you need to define what type of data type you are giving. Okay, so if you are giving integer 32-bit, you need to give integer 32. If you are giving float, you need to give float 32-bit. Okay, so here I am generally created float 32 randomly. Then here I am giving the name, that is assigning the name. Which name is there? Here I am assigning here name. Okay, so after that I need to multiply the, so according to my this I need to multiply, right? According to my graph here I need to multiply. So here I am using multiply x1 and x2. Then here I created a multiply variable, right? The data output will be saved in multiply only. So here I need to define the option. So after this I am using session. Okay, I am just calling the function of session. Then I am running the multiply. Okay, so whenever you are defining anything x1 x2 and multiply, you need to execute this part, right? You need to run this part, then only you will be get the output, right? So those execution, if you want to get those output, means you need to use this session. Okay, so using this session I am running the output file. Then all the, here I am just calling the multiply means the what you have to do exact rules. Okay, the rules I am calling here multiple rules. Then here I am passing all the input data, then I will be get the result in print statement. Okay, so this is what my code. So I will work on in my Google Colab and I will check the output, what is the output I am getting here. Okay, so everybody, if you are free, means you also can open the Google Colab. Previously I told you how to open Google Colab. So after opening the Google Colab, first of all you need to import the package. The package name is numpy as np, and then import matplotlib, sorry not matplotlib, TensorFlow. Okay, here we have a TensorFlow as tf, TensorFlow as tf. Okay, so what is this np, what is this TensorFlow? I think you will be get some doubt. So note one thing, this is actually, instead of calling each and every time numpy, and instead of calling each and every time whenever you need TensorFlow, you need to use TensorFlow word, right? So for that purpose I am going to create a simple object name, that is np and tf. So whenever I need, I will call it as a tf when we want to use the TensorFlow function. When we want to use numpy, I will call it as a np. Okay, so we can do like this. So that is the use of this one. And now what I am going to do means, I already showed you the example what I will do in PPT. So this is my example scenario, x1 x2 multiply, and then we need to run the session. Okay, so this is my scenario. So TensorFlow will be create the nodes to connect the, after creating the nodes we need to connect the operation. So like that, the operation is nothing but multiply operation. When the graph is determined, the TensorFlow engines will be multiplied together. Okay, so now we define one graph. So now it started to multiply with together. Okay, so now we will use, first of all we need to import those two packages. So just to click here, automatically the package will be import. Then next thing, I am going to define some variables as it is same. Here I am defining x1 is equal to tf. Okay, whenever I need to place any variable, we need to use tf dot placeholder. Okay, tf dot placeholder. I am not getting placeholder here. Okay, we imported right tf, then I am calling tf, then placeholder is available, no suggested. Okay, I am not getting placeholder.
parallel stack. I think here the version problem is there. Okay, so the version of the TF will be advanced, means the placeholder whether it will be a deprecate. Okay, so code deprecation is nothing but like each and every versions the code will be deprecate. I think this is the old method what we are here I am using. This is the old method, placeholder TF and all. Here I am not getting placeholder now, so I think it's a old method. So that's why I am not getting. Suppose if I use Jupyter notebook, means what I will get, let me see. Actually this is the Jupyter notebook. Generally it's used for, it's running by using Anaconda Navigator. I already told you what is Anaconda Navigator. So here I am creating the using Anaconda Navigator. I am going to use those. I am creating a new file. Suppose if I here if I get an what is that placeholder, we will work on it. Otherwise I will just tell you how it's working. Import TensorFlow as TF. Okay, so now I need to create one variable name, x1 is equal to TF dot, then I need to import placeholder, right? So here I will check whether the placeholder is available or not. Pad pow print by function, so only this is available. I am not getting placeholder here. Parallel stacks only available. Okay, so better we will go with PPT. I think version problem is there, so I am also installing the version of newest version. Okay, so that's it. Here you can see my main aim is I need to create an x1 node and x2 node, and we will multiply those things and we will get an output result by using this system. So here you can see I am using placeholder and then TF float. Otherwise we will check it using parallel stack. Otherwise just wait a minute. I am going to use placeholder. We will find which version available in placeholder. Okay, so here I am defining a placeholder and I am not getting that such a sum, but I will get an error. Okay, so I will check for error. Like I am giving float 32 and name is equal to, what is the name which I given, variable name x1. Okay, so now I am running this cell. I will get an error, attribute error, no module TensorFlow has no attribute placeholder error. Now what we have to do means we will check through the online about this. Okay, we will check through online how we need to rectify this error. Here I am having a Stack Overflow object has no attribute placeholder. So here you can see we have some answers. Reinstall TensorFlow, we need to install TensorFlow. Okay, TensorFlow compat df, import as df, everything is already be done. Okay, so we need to install the TensorFlow version. This means definitely we will get that placeholder, I think so, but we will try to install in Google Colab itself. Pip install TensorFlow. If you are installing this, you need to use this. So now I am installing TensorFlow. It's collecting the package. It's downloading. Okay, so if you want to install the TensorFlow package, you need to use like this pip command. Okay,
So now it's downloading all the packages. So the current version which I installed is 2.30, 2.3.0 versions I installed. Now I am changing my version, TensorFlow version 2.30 into 1.40. Okay. So after this, now it's successfully uninstalled. I am getting warning, you must restart the runtime in order to newly installed version. Okay, I am clicking this restart version, restart runtime. Okay, so now restarted, I think so. Just wait a minute. Restarting, initializing, then okay. So now again I am importing the TensorFlow, and after this what I am going to do means I will check whether the placeholder is available or not. Yes, now it's available. Okay, so like this we can import our TensorFlow package whenever you need. Okay, so now the placeholder is available in 1.4.0 version only. Okay, the placeholder is available 1.4.0 only, but my current version which I installed previously which version I installed 2.3.0. So now if you want to change this version, you can use here instead of this pip install TensorFlow. Okay, pip install. If you again you need to install the version of latest version, means you can use pip install TensorFlow equal to 2.3. So this will be applicable for both Anaconda Navigator and both Google Colab also. But if you are installing directly using notebook file, you have to use this exclamatory symbol. If you are not installing, if you are installing with the command prompt, that is Anaconda prompt, means you don't need to use these things. Okay, so now what I am going to do means after this placeholder I need to use another one placeholder x2 according to my PPT. Here I created the x1 and x2 and then multiply with this. So I am getting x1 and x2, then placeholder, then here I need to change the value x2. Okay, so now we have a totally two creator, each of load 32 and place with the placeholder name x1 and x2 we defined. Okay, so now we have totally two variables. Now I have to follow, after I am creating a two nodes, I need to pass the two nodes into the multiply operation. So I am going to create now computation. I am defining the computation now. So I am creating a MUL. Okay, multiply is equal to TF dot I need multiply. Okay, so here I am having a lot of option. I need to install the multiply. So I need to call the multiply function. Within this multiply function, I need to save my, here you can see here automatically giving suggestion. Okay, so I need to save my x, I need to pass my x1 and x2. Okay, I need to pass my x1 and x2, and then I need to give the name. What is the name I need to give here? Which name I am using here, which variable name I am using here, same name I need to give here. Okay, so name is equal to this mult. Okay, when I am executing this line, I think it's executed, there is no error. Now after I created this x1 and x2 and multiplied, I need to create this session to get my output result of x1 and x2. When I am passing any data value, I need to get a result. So for that purpose I am using this session. So I am going to define the session. I am opening with, okay, with TF. I am calling the session S capital.
session, okay, and then as, okay, I'm just calling the session function as yes. What is that? SSION. Okay, so like same thing only here. What I am doing, TF or NP, like same thing here. I'm calling the session, and then I'm opening this. Then here I'm opening the result. That is, my output will be saved in this variable name only. So I'm take it as a result, RESU result. Okay. Here I'm defining all the. Here I'm calling sorry, what is the name? SESSION. It will not give suggestion. Why? Because till now I didn't run the particular cell, so I am getting here. So I need to run this session, so I am using run function, and within this, which one what computation I need to do? I need to do the computation multiple, right? So here I am passing the multiple computation. Okay, here I am passing the multiply computation. After this, I am feeding the dictionary. Okay, I am feeding the dictionary. Here I am not getting any suggestion, I think. Okay, I am feeding the dictionary, this variable only. Okay, so what type of dictionary I need to do? So dictionary means generally we have keys and values. Okay, keys and values. Keys is nothing but this is the keys, x1 and x2 is keys. For x1 I am passing the keys, I am giving the key of x1, and I am passing the values for x1. For x1 I am passing the value 1, 32, 3, like that. I am just passing the x1 keys, and this is the keys and this is the values. Like same thing I need to define for x2. Then I am using the comma, then x2. Okay, then I need to pass some data. Here I am creating 3 data, so I need to use here 3, 1, 3. Okay, so now I passed all my input to the multiple, that is computation. So all the data will be passed into the here, then it will be compute all the information. Then using this session I am getting the result, saving the result value. Then if you use print, then result means you will be get an output result for this. See here, 1 into 3, 3. So 32 into 1, 32. Then 3 into 3, 9. So like this you can compute your TensorFlow versions. Okay, so like this way you can compute your TensorFlow version. But according to what we discussed previously, by creating the computational graph, we created and we computed, we see the output. So that is the use of session. That is the use of session and multiply and x1 and x2. Okay, so according to this we find the result. The result is we find it. Okay, so like this same thing you can do for reading the data set. But if you want to load the data into the TensorFlow, you have totally 2 methods. One is load the data into the memory, another one is load the TensorFlow data by using pipeline. Okay, so load the data into the memory means we can easily, for example, if you have low memory of data set like a CSV file or Excel file or text file or JSON file, like that file you having a data set means you can load it directly by using Python code, and you can train the TensorFlow algorithm. Okay, but if you have a large amount of data set, you need to use the API to load the data set, using the pipeline API to load the data set. Why? Because if you take a picture type of data set, or if you take a audio type of data set, we have large amount of data are available, right? So if you want to compute those data within the memory, within the load memory means it's difficult. So that's why we need to use the TensorFlow data pipeline. Okay, so here you can see detail about load the memory. So if you have a data set, it's not a big, that is it's less than 10 gigabyte, you can use the load memory method. Okay, so how you need to load you to use the load memory type means using pandas like that. Okay, so here I will show the demo how to use the pandas. Here I am opening my Google Colab. So here I am having already some default data sets. In Google Colab they are giving some default data set. So here you can see California housing.csv, ministtest.csv, ministrainsmall.csv, right? So you can import those things also. For example, you can import pandas as pd. Okay, then you can read the data set. Dataset is equal to pd dot read underscore csv. Then you can define the where is your dataset. It's in the folder name sample data, right? So you can mention here sample, yes, sample data, and then you can mention now your dataset name. Here California housing test dataset available. You can mention the California test.csv. Okay, so if you are after you done this one, if you are execute this line, I am getting error. Why? Because you need to use single quotes. Then if you are running this cell, then you can print the dataset by using data set.head. This is the first file in your dataset you are printing now. So this is the dataset available default in our dataset. So this dataset is not that much big, right? So it is not a more than 10 GB. Okay, so if you have a more than 10 GB, if you have a less than 10 GB of dataset, you can use the pandas to read that cell, and you can dump the dataset by your local memory. Okay, suppose if you have more than 10 GB, okay, you need to use this method, load data with TensorFlow pipeline. That is using, if you have more than 15 GB of dataset means you need to use the TensorFlow pipeline to dump your dataset. Okay, so if it is a 16 GB also, the memory will be crashed. Memory of your machine will be crashed. So you need to use TensorFlow pipeline only. Okay, so up to 15 GB you can do like this. Okay, if you have a dataset up to 15 GB, you need to do like this. If you have more than 15 GB, you need to use some advanced technique like Spark, PySpark, like that and all. Okay, so this is the use of load the TensorFlow pipeline technique. Okay, so here I am having some demo. Okay, so I hope everybody will understood about this TensorFlow working. Okay, so if you have any doubt regarding this webinar, you may ask now. I will. If you have any doubt regarding this TensorFlow, you may ask now. I will tell you some doubts. I will clarify your doubts. So those who are attending this webinar, please click a like button. Okay, it will be useful for us and it will be motivate us. And those who are new to this channel, please subscribe the channel and hit a bell icon. And the attendance links will be forwarded in our chat box and in our description also. Those who are attending this wonderful webinar, you just click that link and then check it out. Register your names. You will be get a certificate. If you have any doubt regarding this webinar, you may ask now. Okay, so thank you for attending this wonderful webinar. If you have any doubt regarding this webinar, I will tell you the contact number. Okay, otherwise you can contact me on hyt.java@pantechmail.com And if you have furthermore, if you need furthermore upcoming events and furthermore information, you can contact us on WhatsApp, and even Telegram channel is also available. You can join with us each and every day. We will post the events. Okay, then if you need like this webinar for your college, or if you need any internship related to TensorFlow or deep learning, machine learning, or IoT systems, IoT with machine learning, IoT with deep learning, you can contact us those 3 numbers, Mr. Sendil Kumar, Mr. Srinivasan, and Mr. Kumarasamy. Okay, so they will help you for your internships or faculty development program or webinar. Okay, so thank you guys. I hope this session will be wonderful and understand. So we will see on another one nice session. So thank you for this attending this wonderful webinar on TensorFlow. Thank you all. Have a nice day.